In this video, we will see the difference between dipole moment of the bond and dipole moment of the molecule. So if there is a molecule, there has to be some bonds, right? At least one bond is there in any kind of molecule. For example, we have got this hydrogen molecule H2, and there is a bond between two hydrogen atoms. But there is no dipole moment between these hydrogen atoms, okay? No dipole at all. But if you talk about the HCl, there is a dipole moment that exists, and it is denoted like this, arrow pointing from hydrogen to chlorine. So reason why there is a dipole moment is because when the bond is created between hydrogen and chlorine tends to pull the electron that is shared in the bond. And that's why chlorine becomes negatively charged while hydrogen becomes positively charged. So there is equal amount of charge separated by a bond length. Now, if we talk about the H2O molecule, you can see that there are two bonds and then there are two dipole moments. So for each bond, there is a separate dipole moment. So for this one, H1 to O, there is one dipole moment, and for the second bond, there is another dipole moment from hydrogen to oxygen. So if you calculate the net dipole moment for the H2O, it will look like this one. Because we can consider these dipole moments as a factor, and then if you take the resultant, it will look like this dipole moment, which is pointing upward direction. So if you are given a molecule and if you want to find the dipole moment, net dipole moment for the molecule, you will have to consider all the dipole moments in that molecule. For example, in H2O we had two dipole moments, so we have to take the sum of that and then get the resultant. Same way, for complex molecules, there may be multiple bonds, and then you will have to consider all those dipole moments that exist between those bonds to calculate the net dipole moment. And the last example, we have got CO2 over here. In case of CO2, we have got this carbon at the center and oxygen atoms at both the ends. And CO2 is a linear molecule. What it means is that its shape is linear. There exists a dipole moment like this, which means oxygen is more electronegative than the carbon. There exists the two dipole moments from carbon to oxygen. And since this molecule is linear, what happens is that this dipole moment cancels out. There are two dipole moments, opposite direction and same magnitude, so they cancel out with each other. So if you talk about the net dipole moment here, net dipole moment is zero. Okay, so we can say mu is equal to zero. So mu is basically a symbol that is used to denote the dipole moment, net dipole moment. So we have seen four examples in this video. First one is hydrogen molecule where there is no dipole moment exist at all. So net dipole moment is zero here. In hydrogen chloride, there is a dipole moment, right? So mu is not equal to zero in this case. In H2 also, mu is not equal to zero. In CO2, mu equal to zero. So whenever there is a mu is equal to zero, we say that this is a non-polar molecule. And when mu is not equal to zero, we call it as a polar molecule. That's it. That's the difference between dipole moment of the bond and dipole moment of the molecule. Thanks for watching.